Assalamu alaikum students. So today our topic is about the yield of a chemical reaction. So here what does the yield mean? Yield is means the product that is formed at the end of the chemical reactions. So every substance you see around you are made up of chemicals and they are made through the series of the chemical reactions. For example, you take the example of the plastics, composites, phones, computers, pens, printer, artificial fibers, clothes. They are all made using the chemical reactions. And as you know that in a chemical reactions, the reactants combine to form the products. So for example, if you need the 1000 kg of the product, so here the question rises that how much reactant should be needed in order to produce 1000 kg of the product. So for that, in order to calculate this calculation, we must know the two things. What are the two things? The formula masses of the reactants and the products. Secondly, the balanced chemical equation. If we know these two things, we can easily calculate the given product mass of the product. So if you carry out the reaction, it is unlikely that you will get as much of the product as you worked out. So here we know that there are two types of the product here: actual yield and the theoretical yield. We have two types of products, or we have two types of yield: the actual yield and the theoretical yield. So what is the actual yield here? Actual yield is the yield or the product that is formed after the series of the experiment. This is the product that is obtained after the series of experiment or after the end of the chemical reaction. And what does the theoretical yield means? Theoretical yield means it is the predicted amount of the product that is calculated through the balanced chemical equation. So there is a difference between the theoretical yield and the actual yield. So actual yield is the actual mass that is being produced after the end of the series of experiment or after the end of the chemical reaction, while as the theoretical yield is the predicted amount of the product that we just calculated through the balanced chemical equation. Okay, so there is a difference between them. For example, if we have just say that if we combine these reactants and we get the product, for example, from the balanced chemical equation, the predicted amount of the product that should be gained was 1000 kg. Okay, so from the balanced chemical equation or from the calculations, we get that after combining the reactants, the actual or the calculated product would be 1000 kg. But after when you just do the same experiment in the real time, you see or you observe that you only get the 800 kg of the product. So this is the actual yield that you have obtained after the end of the experiment or after the end of the chemical reaction, and it is a predicted yield here, theoretical yield that we have calculated through the balanced chemical equation. So you clearly see the difference between the theoretical yield and actual yield. So here the question rises that why there is a difference here. This difference might be because of the conditions, external conditions or environmental conditions that have applied on the chemical reaction, and as a result there is a decrease in the actual yield. So we will discuss some of the factors that are affecting the theoretical yield or the actual yield here. So it is useful to think about the reactions in terms of the percentage yield. So the mass of the product that we actually produces is called as the actual yield, while the mass that could be possibly produced, or the predicted amount of the product that we get through the balanced chemical equation, is called as the theoretical yield. So this is a formula for the percentage yield. For example, if you want to find out the percentage yield, that how much product that you have produced in percentage, there is a formula for that: actual yield divided by the theoretical yield multiplied by 100%. Okay, so here the actual mass of the product produced divided by the maximum theoretical mass of the product possible. So actual mass of the product produced is actually the actual yield, and maximum theoretical mass of the product possible is the theoretical yield. So here you can see that if the 1000 kg was the product predicted for a reaction and only 800 kg is being collected, that is the actual yield, how much percentage yield would be? So here, if the 800 is the actual yield and the 1000 is the theoretical yield, you can easily find out the percentage here. Two zeros will be cancelled here, and you will get the 80% yield. Okay, now we will move towards the factors that affecting the rate of the percentage yield or the actual yield here. So we will take one of the example of the calcium carbonate that we called as limestone. So this is a decomposition reaction of the calcium carbonate, in which calcium carbonate at high temperature decomposes into calcium oxide plus carbon dioxide. Okay, so one of the reason of the decrease in the actual yield is that some of the limestone is lost as a in the crushing process or in the rotating kiln. So this is also one of the reason that why the actual yield is reduced as compared to the theoretical yield. And because of the impurities in the limestone, the 100% of the calcium carbonate doesn't convert it into the calcium oxide here, that is the desired product that we wanted. So this is also the reason that in the decrease in the actual yield. So this is one of the reason that reaction may be reversible. So what is the reversible reactions? We have two types of reactions: complete reaction and incomplete reaction. The complete reaction is also called as irreversible reaction. So what is the irreversible reaction? Irreversible reaction is a reaction in which all of the reactants is converted into products. For example, carbon plus oxygen converted into carbon dioxide. This is a complete reaction in which all of the reactants is converted into the products. So what about the incomplete reaction? Incomplete reaction is also called as reversible reaction. So what are the reversible reactions here? So reversible reactions are the reactions in which the reactants is converted into the products, and at the same time the products is converting into the reactants. So here there is no completion of the reaction, and the reaction just goes on and on, in which the reactants converted into the products and the products again converted into the reactants, and the reaction doesn't goes to the completion reaction. So because of that, there would be no production of the maximum actual yield. For example, if we want to produce the ammonia here, but as you can see that ammonia is produced with the reversible reaction, so there would be no completion of reaction. the products is converted into the reactants is converted into the products, and the product is at the same time is converting into the reactants. So because of the reversible reaction, we can't get the maximum amount of the product that we desire. Okay, so this is one of the reason that actual yield is less than the theoretical yield. So our fourth reason is that some reactants may react to give unexpected or unwanted products in the alternative reactions. For example, if the calcium carbonate is decomposing into the calcium oxide and carbon dioxide, and the amount of the product that we require, or the product that we require in this reaction, is the calcium oxide, we don't need a carbon dioxide in this reaction. So you can say that this carbon dioxide is an unwanted product. And the calcium oxide is the required product. So here you can see that some of the mass of the calcium carbonate is utilized in converting into the carbon dioxide, and this is one of the reasons that we have the less required actual yield. So this is one of the four reasons that why the actual yield is less than the theoretical yield. So some of the product may be lost in handling or left in apparatus. So this is the handling issue by the workers that are working in the lab or in the industry during the experiment. So the reactants may not be pure. For example, if the calcium carbonate is not pure and is impure, so some of the mass is lost because of those impurities, and only less amount of the calcium carbonate would be converted into the calcium oxide. So this is also one of the reasons that the actual yield is less than the theoretical yield. So some of the desired product may be lost during the separation from the reaction mixture. So this is also one of the handling issues, that some of the product is lost because of the separation. As you can see that this is a lime kiln. So some of the product that is being produced after the end of the chemical reaction maybe get stick with this lime kiln. And what is the lime kiln here? This is a vessel in which the calcium carbonate has been given the high temperature and it is converted into its products. So some of the calcium oxide gets stick to its lime kiln, and this is also one of the reason that we get the less amount of the actual yield as compared to the theoretical yield. Okay, now we will move towards the calculating the percentage yield. So here we will be given some of the numericals, so we will convert the percentage yield. So there is a word problem that limestone is only made of the calcium carbonate. In the production of the calcium oxide, crushed lumps of the limestone are heated in a rotating lime kiln. The calcium carbonate decomposes to make calcium oxide and the carbon dioxide gas is given off. So a company processes 200 tons of the limestone a day. It collects 98 tons of the calcium oxide. The useful product, what is the percentage yield of the reaction in the kiln, assuming limestone contains only calcium carbonate? So here the relative atomic masses of the calcium, carbon and oxygen has been given to you. So we will start that what the chemical reaction has been given here. Here the calcium carbonate is converted into the calcium oxide here. So we will first of all write the chemical reaction for that. Here the calcium carbonate decomposes into calcium oxide and the carbon dioxide here. And the actual yield has been given to you here, that a company processes 200 tons of the limestone a day. So this means that this is the actual amount of the reactants and the products, where the calcium oxide has been given that 98 tons. So this is the actual yield here. 98 tons is the actual yield that is being produced after the end of the experiment. Now we have to find out the percentage yield. So we know that for the percentage yield we must know the two things. What are the two things? Actual yield and the theoretical yield. So we know the actual yield, and now we will calculate the theoretical yield in order to find out the percentage yield. So we have learned that in order to find out the theoretical yield, we must know the two things. What are the two things? Formula masses of the reactants and the products. Second is the balanced chemical equation. So we have already write the balanced chemical equation for the decomposition reaction of the calcium carbonate, and now we will find out the formula masses of the reactants and the products. So we are only concerned with the calcium carbonate and calcium oxide. So we will find out the molar masses of both of the reactants and the products here. So for finding out the molar mass of calcium carbonate, so relative atomic masses has been given to you, so you can easily calculate the formula masses here. So calcium, the relative atomic mass of the calcium is 40 plus relative atomic mass of the carbon is 12 plus relative atomic mass of the oxygen is 16, and there are 3 atoms of 16, so you will multiply with the 3 here and you will get the answer, that is 100. Now you will find out the formula masses of the calcium oxide. So relative atomic mass of the calcium is 40 and the relative atomic mass of the oxygen is 16, so you will get the answer, that is 56. So we have the balanced chemical equation. Now we find out the molar masses of the reactants and the products, so we can easily find out the theoretical yield. So this is the first step. What is the first step here? Is to find out the balanced chemical equation and the formula masses. So this is your first step of finding the solution. Now we will move to the second step. In second step you will take the ratios here. How you will take the ratios? Okay, so how you will take the ratios here? If 100 tons is producing 56 tons of calcium oxide, so this ratio we have taken it from the formula masses of the calcium carbonate and the calcium oxide. If the 100 tons of the calcium carbonate is present, then how much of the calcium oxide would be produced? So if 100 tons of the calcium carbonate is present and 56 tons of the calcium oxide is present, so how much calcium oxide would be present if the 200 tons of the calcium carbonate is present? So we have taken these 200 tons from the given mass here. So here you will just do the cross multiplication. So here the x is being divided. When moved to the other side of the equation, it would get multiply here. And what is the x here? X is the mass of the calcium oxide when the 200 tons of the calcium carbonate is being given to you. So here it would becomes 100 multiplied by x is equals to 56 multiplied by 200. we only want the value of the x here, so we will move the 100 to the other side of the equation. So it would becomes x is equals to 56 multiplied by 200 divided by 100. So 100 ones are 100, 100 twos are 200. So 56 multiplied by 2 is equals to 112 tons. So this is the second step of finding out the theoretical yield here. So if the calcium carbonate, if we have the 100 tons of the calcium carbonate and it produces 56 tons of the calcium oxide, then how much of the calcium oxide would be produced if we have 200 tons of the calcium carbonate? So here you just take the ratios here and you do the cross multiplication, and you will have the answer of the X as 112 tons. So this 112 ton is the theoretical yield that we have find out from the balanced chemical equation and the formula masses, and by taking the ratios here. Now we will put the theoretical yield and the actual yield that has been given to you in the question into the formula. So here the formula is percentage yield is equals to actual yield divided by theoretical yield multiplied by 100. So here the actual yield that has been given to you is 98 divided by theoretical yield is 112 multiplied by 100%. So you will get the answer that is 87.5%. So this is our third step of finding the percentage yield. Okay, now we will move towards the question number 1 and question number 2 of the exercise. So question number 1 states that why it is good for the environment if industry finds a way to make products using high yield reactions and processes that waste as little energy as possible. So there would be two reasons. So one is the reason is that reduction in resource consumption. And second reason is that lower energy emissions. So reduction in the resource consumptions, which means that high yield reactions ensure that more raw materials are converted into the products and reducing the rate for extracting and processing additional resources which can deplete the nature reserves. So lower energy emissions. It possesses that use less energy contributes to reduced greenhouse gas emissions, which helps to combat climatic change by lowering the industrial carbon footprint. Okay, so now we will move towards the question number 2, that is about list the factors that can affect the percentage yield of a reaction. So we have already discussed that what are the factors here. First factor is that reversible reactions. So because of the reversible reactions, not all of the reactants converted into products, because at the same time reactants is changed back to its reactants. So because of that, not all of the 100% of the reactants is converting into the products. Because of that, there would be less product yield or the actual yield would be produced. Another factor is unexpected products. For example, we take the example of the calcium carbonate. When we decompose the calcium carbonate, actually the desired product that we wanted is calcium oxide, but along with it carbon dioxide is produced. So some of the mass of the calcium carbonate is utilized in converting the carbon dioxide instead of the calcium oxide. So here this is the unwanted product is produced. So because of this unwanted production of the unwanted products, there would be reduce in the actual yield. Another factor is mishandling. So because of the workers mishandling, some of the products may be lost after the production of the desired product that we wanted, or because mishandling can be happen when they are when they are just putting the calcium carbonate in the reacting kiln or in the pretus. So maybe in that step, because of the mishandling, they can reduce the amount of the reactants and the products here. So fourth reason is impurities of the reactants. So because of the impurities of the reactants, not all of the reactant changes into the products, but because of the impurities within the reactant, they can be converted to other forms of the products, or they can produce unwanted products, or the side reactions may happen. So our fifth reason is some of the desired product lost during its separating from the reaction mixture. So at this step, some of the product might be present or might stick with the pretus, or some of the desired product might lose during the separation from the reaction mixture. So these are some of the reasons that can affect the percentage yield of a chemical reaction. Okay, now we will move towards the question number 3, in which the ammonia gas is made by heating the gases nitrogen and hydrogen under the pressure in the presence of the iron catalyst. So here you can see the reversible reaction in which the mass of the nitrogen and the mass of the hydrogen ammonia has been given to you. So here nitrogen and hydrogen undergoes the reversible reaction and makes 2 moles of the ammonia. And here the mass of the nitrogen has been given to you, that is 7 gram, and the mass of the ammonia has been given to you, that is 1.8 gram. Okay, so now we will move towards the first step. Here we have to find out the percentage yield. As we know that in order to find out the percentage yield, we must know the 2 things, actual yield and the theoretical yield. So percentage yield is equals to actual yield and the theoretical yield. What is the actual yield? Actual yield is the yield that is being produced after the series of experiment and the chemical reaction in the industry, whereas the theoretical yield is the calculated or predicted amount of the product, so which is calculated through the balanced chemical equation. So in order to find out the theoretical yield, we here 1.8 gram is the actual yield here that has been given in the question. Now we will find out the theoretical yield. So in order to find out the theoretical yield, we must know the 2 things. What are the 2 things here? Molar masses of the reactants and the products, and second is the balanced chemical equation. So we already know the balanced chemical equation, which is already been given in the question, and here we will just find out the molar masses or formula masses of the reactant nitrogen and the product, that is ammonia 1.8 gram. So we are not concerned with the hydrogen here, we are only concerned with the nitrogen and the ammonia here, because here the masses of the nitrogen and the ammonia has been given to you. So we will find out the molar mass of the nitrogen. So here the relative atomic mass of the nitrogen is 14, and there are 2 atoms of the nitrogen here, so you will multiply with the 2, so that would be equals to 28. Now you will find out the formula mass of the ammonia. So here relative atomic mass of the nitrogen is 14 plus relative atomic mass of hydrogen is 1, and there are 3 atoms of the hydrogen, so we will multiply with the 3, so that would be equals to 17. Okay, now so this is our first step, that we have to fulfill this criteria, in which we have to find out the molar masses and the balanced chemical equation. Now we have the formula masses, we have the mass in gram, we can easily convert the mass of the nitrogen and ammonia into moles. So our second step is to find out the number of moles of nitrogen and ammonia and to find out the ratios here. So now we'll move toward the second step, in which we will find out the number of moles of ammonia here. Number of moles of ammonia, sorry, moles of nitrogen. So here formula for number of moles is mass in gram divided by formula mass. So we will just substitute out the values here. Mass, here the mass of the nitrogen is 7 divided by formula mass of the nitrogen is 28. So 7 divided by 28 is equals to 0.25 moles. Okay, now we have to find out the number of moles of ammonia. Okay, so we are finding out the theoretical yield. So here we will not put the value of the 1.8 in the formula, because it is actual yield. We have to find out the mass of the theoretical yield of ammonia. Okay, so for that reason we will take the ratios here. Okay, as you can see from the balanced chemical equation, 1 mole of ammonia is producing 2 moles of the 1 mole of nitrogen is producing 2 moles of ammonia. So here we will take the ratios according to the balanced chemical equation. This is a balanced chemical equation. So from the balanced chemical equation, you can see that here 1 mole of ammonia is producing 2 moles of 1 mole of nitrogen is producing 2 moles of ammonia. So here you will write it like that. Now what happened? How many moles of the ammonia would be produced if we have 0.25 moles of the nitrogen here? Okay, so from the upper part of the ratio, these ratios of the nitrogen ammonia we have taken from the balanced chemical equation, and these are the values that we have taken from the given moles. Yes, the moles are been given, because here the mass of the nitrogen has been given to you, you just convert it into moles. So here the given moles that has been given to you of nitrogen is 0.25 gram. You have to find out the moles of ammonia here. So you will do the cross multiplication. So 1 multiplied by x is equals to 2 multiplied by 0.25. What is the x here? X is the moles of ammonia. So here x is equals to 2 multiplied by 0.25 would be equals to 0.5 moles of ammonia. Here we have to find out the mass of ammonia. Here we have find out the number of moles, we can easily find out the mass of ammonia. So for finding out the mass in gram, the formula for finding out the mass in gram is number of moles into molar mass or formula mass. So moles of the ammonia is 0.5 and the molar mass of the ammonia is 17. So you will multiply it and you will get the mass of the ammonia, that is 8.5 gram. Okay, and what is the mass of ammonia here is, it is the theoretical yield. Theoretical yield. So you can see that here the actual yield has been given to you and you have already find out the theoretical yield. You can find out the percentage yield here. So what is the actual yield of ammonia? Here it is, that has been given to you in the question, that is 1.8 gram. So you just substitute out the values of the actual yield, that is 1.8, theoretical yield is 8.5, and then multiply with the 100%. You will get the percentage yield as 21.18%. Okay, so this would be our third step, and our second step is to find out the number of moles and find out the moles through the taking ratios. So in our first step we have find out the molar mass and the balanced chemical equation. Through that we have find out the number of moles of nitrogen. Now in the second step we have find out the moles here and moles of ammonia through the ratios, and by taking the ratios we have find out the moles of ammonia, then converted the moles of ammonia into gram, and this mass of the ammonia is the theoretical yield, and then just substitute out the actual yield and theoretical yield in the formula and you will finally find out the percentage yield. Okay, now we will move towards the question 4, in which the sodium hydrogen carbonate is converted into sodium carbonate through the thermal decomposition, and the mass of the sodium hydrogen carbonate and the sodium carbonate has been given to you. First of all we have to write out the balanced chemical equation for the thermal decomposition. So here sodium hydrogen carbonate decomposes into sodium carbonate and carbon dioxide along with the water. So you can see that here the is that a balanced chemical equation or not. So you can see that in the product side there are two sodium are present, so and there is only one sodium is present on the reactant side, so here you will add the 2 here in order to balance the sodium atoms on the reactant side as well as in the product side. So how many carbon atoms are there in the products? 1 and 2. So yes, here the 2 carbon atoms are also present in the reactant side. And how many oxygen are there? 3, 4, 5 and 6. 6 oxygen are present in the product side. Yes, and as well as 3 to the 6 oxygen is also present in the reactant side. And now we'll talk towards hydrogen. 2 of the hydrogen is present on the product side and 2 of the hydrogen is present in the reactant side. So this is the balanced chemical equation. We have done the first part of the question number 4 part A. Now we will move towards calculate the percentage yield the student obtained. So the mass that has been given in the question is, here the mass of the sodium hydrogen carbonate is 16.8 gram and the mass of the sodium carbonate is 9.20 gram. Okay, now what we have to do, you have to find out the percentage yield. As you know that this 9.20 is the actual yield here. This is the actual yield. So in order to find out the percentage yield, we must know the two things, actual yield and the theoretical yield. We know the actual yield, now we will find out the percentage yield for the for finding out the percentage yield. Actual yield divided by the theoretical yield multiplied by 100%. So in order to find out the theoretical yield, we must know the two things. What are the two things? Formula masses of reactants and products. Second, balanced chemical equation. We have the balanced chemical equation. Now we will find out the formula masses of the reactants and the products. So molar mass or formula mass of sodium hydrogen carbonate is 14 plus 1 plus carbon 12 plus 16 multiplied by 3. So that would be equals to 84. Now we will find out the formula mass of the sodium carbonate. So that would be sodium is, yeah, that is 23. Yeah, sorry, it was 23 here. Okay, so 23 multiplied by 2 plus 12 plus 16 multiplied by 3. So that would be equals to 106. So the formula mass of the sodium hydrogen carbonate is 84 while the sodium carbonate is 106. Now we will convert the mass of the sodium hydrogen carbonate into moles. So we have up till now completed the first step, in which we have the balanced chemical equation and the formula mass. Now we will find out the number of moles of the reactants here in order to find out the moles of the product. So moles of the sodium hydrogen carbonate. So for finding out the number of moles, we know the formula mass in gram divided by formula mass. So here mass is 16.8 divided by 84. So that would be equal to 0.2 moles. Okay, now we will find out the moles of the sodium carbonate here. So as you can see that we can't put the value of the 9.20 in the formula in order to find out the moles, because this is the actual yield. In order to find out the theoretical yield, we will find out the number of moles of the sodium carbonate through the ratio method. So from the balanced chemical equation, you can see that 2 moles of the sodium hydrogen carbonate is producing 1 mole of sodium carbonate. 1 mole of sodium hydrogen carbonate is producing 2 moles of sodium carbonate. 2 moles of sodium hydrogen carbonate is producing 1 mole of sodium carbonate along with the production of carbon dioxide and water. So now we will take the ratios of the moles here. Here 2 moles of the sodium hydrogen carbonate is producing 1 mole of sodium carbonate. Then how much moles of the sodium carbonate would be produced if we have 0.2 moles of the sodium hydrogen carbonate? So here we will do the cross multiplication. And what is the X here? X is the moles of sodium carbonate. So here 2 multiplied by X is equals to 1 multiplied by 0.2. In order to find out the value of the X here, 2 is being multiplied here. When moved to the other side of the equation, it would get divided with the 0.2. So X is equals to 0.2 divided by 2. So that would be equals to 0.1 mole. So in order to find out the theoretical yield, we must convert the moles of the sodium carbonate into mass here. So for that, we know the formula for finding out the mass here. Mass in gram is equals to number of moles multiplied by formula mass of the sodium carbonate. So the number of moles is 0.1 multiplied by formula mass is 106. So that would be equals to 10.6 gram. Okay, so what is the 10.6 gram here? It is the theoretical yield here. Okay, so now our final step here, this was a step 2. Now we will move towards the step 3, in which we will find out the percentage yield. Percentage yield is actual yield divided by theoretical yield multiplied by 100%. So what is the actual yield here? The actual yield that has been given in the question is 9.20 gram. And what is the theoretical yield here? 10.6. So 9.20 divided by 10.6 multiplied by 100%. So you will get the answer, that is 86.79%. So this was your actual percentage yield.